Hello, in this video we are going to see geometric series intuitively and formally. This is what we have seen in the previous video, and we saw that if we define this, then in equilibrium we can deduce that y is equal to 1 divided by this, which is this that we call the multiplier, which means that with an injection of $1 we get a GDP or income of $5. So multiply 1 times 5. Now we want to deduce this, but without using this definition. So we're going to obtain this expression mathematically. So what we want to prove that if here I should have used C, but I have already R, so R is exactly C. So if R or C is less than 1, that is going to be the case for consumption, then we have to prove that 1 plus C or R plus C or R squared, etc. Give us this result. So we're going to prove this intuitively and formally. First, intuitively, if R is 0.5, then this is 1 divided by 1 minus, and R is 0.5. So here we have 1 liter minus half a liter, and then this divided by this is 2. So we want to see that in this case, if R is 0.5, the result is 2, and we want to see it intuitively. But it's quite easy to see intuitively because we have to sum 1 plus R, which is half of this, plus R squared, which is half of the half, plus this, etc. So to show that this distance x is 2 is very easy, because simply if this is 1, this is another 1. So geometrically you can see that x is 2. That is what we wanted to show. Now if R is something like, for example, 0.8, then you plug in this value and then you get 1 divided by 0.2, which is 5. So this is not so intuitive anymore. We can do something as easy as this. So now we are going to prove formally that if modulo of R is less than 1, then we are going to prove formally this expression. So x is, well, you can jump to the next video if you don't like a formal thing, but if you like it, let's go on. So x is approximately equal to this expression with, for any n, let's say if we have here n equal to 4, so we stop the sum in the term 4 minus 1, 3, so R power 3. So we stop here, R power 3, we stop here. So we don't say that it's equal because we are missing this part, we stop here, but it's approximately equal to that. So I repeat exactly the same, and now what we are going to do, we are going to multiply both sides times R. So you have this times R, and here times R, you have R, and here you have this times R, which is this. Now we don't need this anymore. I will take it away. And now we are going to subtract this expression minus this expression. So you have x, which is common factor of 1 minus r, and here you have 1, this 1, and then you have r minus r, cancel out, this minus this, cancel out, and then you have minus r power n. So this is what we have. So we can isolate x, so we can say that x is approximately equal to this expression, approximately, because we are missing this part. Now if we want to take exactly the sum of the infinite term, then we take the limit of this expression when n tends to infinite. So this, in order to calculate this, we plug this infinite. Instead of n, we write here infinite, so we get this expression. And this expression tends to 0 if the module of r is less than 1, which you can see clearly here. You have r, for example, in this case, you have r, then r squared is smaller and smaller and smaller, so in the limit is 0. So if this is 0, then this term is not here anymore, is 0, and then you get 1 divided by 1 minus r, which is what we wanted to prove. And this r is general, doesn't have to be 1/2, it could be 0.8, 0.9, any value, as long as this condition fulfilled. Okay, so see you in the next video. Thanks for watching.